Welcome to another video. In this video we are going to solve reverse linked list problem from the Leetcode. In this problem they will give a linked list and we need to reverse that linked list and return the head of the reversed linked list. So approach is quite simple, but we need to understand like how we are rearranging those pointers. So in order to reverse a linked list, we don't have to create one more linked list, or we can do it while going through the linked list. The way we do it is, if you observe the reverse linked list, in the initial linked list 1 is pointing to 2 and 2 is pointing to 3 and 3 is pointing to 4 and so on. So in the reverse linked list 2 will point to the 1 and 3 will point to the 2. We just have to reverse this direction of the next pointer. So in order to do that, we need to understand the little bit about how this changing of variable happens. Let us start writing the solution using the same technique. We don't really use any extra space, we just try to reverse these things. So for that we will initially our current, we will declare a node pointer which will point to the head of the linked list, and for head our previous node is null, so in Python we use none for that. So as long as we have a node, we will continue this reversing next pointer operation. So what we have to do is, so once we reverse these things, let us say now 1 is pointing to 2, and if we reverse this thing, let us say we make it as 2 points to 1, then once again we have, if you want to go back to 2, that is not possible. So in order to do that, initially we will store a variable named next node. So next node will be current node dot next, current dot next. So now we have the next node, we can reverse the direction of these arrows. So now we are at current node, and current dot next we have to update. Current dot next will be previous. We are just reversing the direction of the arrow. So current dot next will be previous, and after that we need to update the previous, because for the next iteration our current node will become the previous node. So previous becomes current, and then what we are going to do is our current node will be next node. And after doing all these things, what is going to happen? So we will come till the end of the list, and 5 will be pointing to 4 and 4 will be pointing to 3. Like that we get a structure, linked list. But we haven't updated the head. So our head will be, our current node will be pointing to the end length, none. So our head will be previous. Then after this, what we can do is we can return the head. I think this solution makes sense. We will go through the diagram as well if this solution is working. Let us submit this solution and check whether it passes the initial test cases. Yes, as you can see here, this solution is passing all the test cases. Let us check the diagram as well. So whenever we are at a current node, we have to change the direction of the node. So current dot next, instead of pointing it here, we are updating it to previous. So that is this line. This 14th line corresponds to changing the arrow direction. And then we already have stored the next pointer, that is next node will be pointing to the next node before reversing. So then what we are doing is our previous will become the current. So our previous will come here. We will add a text here, so that after that our previous, not here actually, previous comes here, and our current will become this node. So we will add one more text here so that we can understand this solution little bit better. So after executing these lines, our linked list will look like this. If this is the initial state and then we change the direction of the next node, and then we will move to the previously stored next node. So after doing all these things, we will update the head of the linked list, and then we are returning the head. So before submitting the solution, let us discuss about time complexity. For time complexity, we will go through the list only once. So our time complexity is O of n. And for space complexity, what is going to happen? So we are not really using any extra space here. Only extra space, no, we are not using any extra space. So our space complexity is constant. So let us submit the solution and check whether it passes all the test cases or not. Yes, as you can see here, the solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video. If you like content related to data structures and algorithms, you can subscribe to my channel.